Hello, and welcome to EURAXESS Smart Talks.
The Smart Talks podcast series is an EU-funded EURAXESS project which provides information and assistance to researchers at any career stage.
EURAXESS support the EU research area in its ambition to create a single borderless market for research, innovation and technology in the EU.
We support researchers in mobility, careers within and outside academia, innovation and entrepreneurship.
We strive to increase scientific collaboration between Europe and the world. Hi, I'm Daria, a senior expert at EURAXESS National Contact Point in Latvia.
And I'm Jovan, a teaching and research assistant from the Faculty of Mechanical Engineering in Niš, Serbia.
And you are listening to the EURAXESS Smart Talks podcast.
Jennifer Kefauver is a mechanobiologist with a background in structural biology and membrane protein biochemistry. Her research career has been devoted to answering questions about how cells sense and respond to mechanical force. She earned her PhD at Scripps Research, where she used cryo-EM to study mechanical activated ion channels in the labs of Nobel laureate Aranđelović and cryo-IM structural biologist Andrew Ward. Supported by Marie Skłodowska Curie European Fellowship, she moved to Switzerland to expand her expertise into membrane biology and cell signaling at the University of Geneva in the lab of Robbie Lewitt.
She is now a postdoctoral fellow in Oviedo in northern Spain at the Nanomaterials and Nanotechnology Research Center, a branch of the Spanish National Research Council, where she studies rare laminopathies like the Pelget-Huet anomaly and their effect on nuclear structure. This career shift to a more clinical perspective was enabled by a postdoctoral fellowships from the Aristos program, a Maria Skłodowska-Curie co-fund mechanism provided by the CYBER, the Spanish Biomedical Research Network for Rare Diseases. By integrating structural biology, mechanobiology, and epigenetics, she aims to uncover new insights into nuclear organization and the interplay between histone modifications and the nuclear lamina. Thank you very much, Jennifer, for joining us.
Thank you.
Could you tell us, please, about your career path in academia and how you decided to apply for MSCA grant?
Yeah, so as you said, I started at the Scripps Research for my PhD. And when I was about to graduate, I was thinking about what the advantages of staying in academia versus going into industry or consulting were. And, it's not the money or the career stability, but the big advantage I felt of staying in academia was this ability to live internationally, to do research in any part of the world. And I had met a bunch of postdocs from all over the world in San Diego, and there were a lot of people from different European countries, and I was super interested in their perspectives, in the differences that they had seen between the US and Europe. And so I was thinking about going to Europe for my postdoc. And at the same time, I had met the man who would become my husband, and he's from Spain, and he also wanted to go. Thank you. He also wanted to go be closer to home, and so we were looking for a place to go that would advance our careers. And we decided on Switzerland, and I applied to the Marie Curie European Fellowship in order to do that. Americans are eligible to do that. I had to look that up. And I got that fellowship. And it enabled me to do my postdoc there in Switzerland under very nice conditions. I unfortunately, or I guess depending on how you view it, fortunately was in Switzerland for the pandemic. So my ideas of having adventure and building my European network were curtailed a little bit. But it was also, in another way, Switzerland was a really nice place to be during the pandemic. They handled everything with a lot of transparency. So I think we felt really safe there. But in spite of the pandemic, I still managed to get a really nice postdoc experience in Switzerland. And then, we were thinking about what our next move was. And we wanted a place where we could stabilize. And so we ended up choosing Oviedo in the north of Spain because this is my husband's hometown. And I was actually really delighted to learn that there was a lab here doing the kind of work that I was interested in expanding my career into. I wanted something that was more clinical and also something that was more computational. I really have a lot of excitement about this computational biology direction that the
A
field is
little
going.
bit, one follow-up question. You know, when we usually consult the people who want to apply for Maria Skłodowska-Curie, it is very hard to find a specifically dedicated topic. Yeah, this is a challenge for someone who browses all these possibilities. How was it with you?
So I chose the lab first and the topic
Okay.
first, and then applied to the fellowship because, otherwise it's really hard to like try and match your own interests to a specific topic. For the European fellowship, I think there was a really broad possibility of ways that you could apply for this co-fund one that I used to come here. My lab had already, so the way the co-fund works is that a bunch of groups come together to apply for a set of Marie Curie grants. So my lab had already been involved in that program. So the topic was matched already.
Lucky you.
Talking about your topic, we made somewhat of a clumsy introduction to your biography and your research field. Could you correct us and maybe more directly explain to us what you do and what your research is all about?
Yeah, so I'm trained as a structural biologist and a molecular biologist, but I really think of myself as a mechanobiologist. I'm really interested in the way that mechanical forces are sensed and translated by cells, and I especially am interested in the molecular details of that. I think it's a really fundamental question in biophysics, and it's also a really interesting way to think about all of the ways that biology has developed these mechanisms for understanding physical force. I think the other thing about mechanobiology is that it covers so many more human systems than we originally imagined. Like, of course, our sense of touch and pain are mechanical in nature, but also itch and proprioception, like where our limbs are in space, and a bunch of fundamental developmental processes like the growth of bone. Malaria resistance is related to mechano's transduction. And I think exploring all of these ways that mechanical forces affect our health is really the direction I want to
go. I'm interested because my field of study primarily is in structural engineering, so we are not in the same dimension. What the structures that I study are usually much larger. But I'm interested knowing that and that we do some research at my faculty as well as in biomedical research, bone scaffolds and stuff like that. How difficult is it to do experiments and simulation taking into account the small scale of cells? Do you apply finite element method? Do you use some specific instruments for the mechanical tests, universal testing machines? Can they be applied? Are there additional systems that need to be introduced and so on?
Yeah, so I'm coming from the structural biology perspective, and our idea is that structure gives us information about function. So we're kind of going the other direction. We look at the things and then try to back calculate how those structures of these biological systems would provide the functions that they do. And so I've done that with the mechanosensitive ion channels. My PhD projects were on piezo1, which is a gentle touch sensor. Well, the piezo family is a gentle touch sensor, and also on the volume regulated ion channel, that's a sensor for osmotic forces. And actually, my PhD was about solving these structures with the idea that it would give me the answer to how these things function. And in the end, it ended up being much more complicated than that. The first structure just gives you the shape. And it wasn't really until my postdoc that I got to start asking these functional questions, where I solved a structure of a yeast mechanosensitive organelle that the structure was already known, that basic, what is the shape of this thing, was already known. And what I was able to see was how lipids were bound to that structure. And that gave us some clues as to how lipids and proteins interact to sense mechanical forces. So it's really several steps before you get that back calculated information.
This sounds tricky. People are going to the bachelor's and thinking, I will cure cancer, and they end up with all this, atomic
There's lots of
structure.
steps in between.
And sorry, this is how it goes.
Yes, absolutely.
But these are like fundamental science, like fundamental questions. Do you envisage any like applicability?
So now I've started this project that's about rare diseases. The one that my Marie Curie co-fund project is about is Pelgar-Hewitt anomaly, which it's a rare disease that causes this change in the nuclear structure of neutrophils. So neutrophils are the first responders of the innate immune system. They have this funky nuclear structure. It's sort of lobulated. It's not known why that structure is the way it is. There's some idea that it helps the neutrophils squeeze through the blood vessels to get to sites of infection, but even that's not clear. And besides this rare disease, there's also another set of rare cancers called myelodysplastic syndromes that also experience this change in the neutrophil nuclear structure. And so my question is about, okay, if the role of that lobulated nucleus is to squeeze through tight spaces, then mechanical forces have to have some role. And are they doing something interesting there? And can we take that information and go back to help these patients with these rare diseases or these rare cancers?
It's like something like gene therapy, or no, it should be applied like to cure this, or at least to have some pause in development of this disease.
Yeah. So the idea is basically to use so the idea we have is that the important factor in this squeezing is related to modifications to the epigenetics of the nucleus.
Okay.
So these are histone marks, and our idea is that maybe they're interacting with the structural proteins of the nucleus. And there are drugs that affect the histone marks. There are drugs that can affect interactions between proteins. And so these are the kind of things that might be able to help those patients if they're relevant.
Yeah, of course. Hard things, not only to understand, but you really understand how this a very huge topic for, of course, if we are saying rare diseases, then it means rare. Not all the patients will need like these medications, etc. And how and the prices go up already when we are talking about something like that. It's very personal approach, so to say, individual.
This is precision medicine.
Yes, but there is definitely there is a future in that. At least if you won't have the direct results, at least it in some way will give us understanding of how it should work or can work.
Exactly.
But you have an experience and can compare research environment in America. Let's get a little bit back from the field into the reality. So in America and Europe, could you shortly give us an overview and maybe tell about the differences or similarities in both? And could you tell us why you decided to choose Europe for your mobility? Sorry for this question, you've already answered on it, but let's stay focused. Okay, you switched from US to Europe and you have two places, and I assume that the places are pretty different, like Switzerland and Spain. Let's focus on them.
Yeah. So, okay, the thing that is famous about the American system is the work culture.
Yeah.
We like the long hours. We like the no vacations life. And
No
while
parental leave.
yes, absolutely not. And well, my experience, from my supervisors, I never had that kind of pressure. But from my peers, they were working long hours in the lab. So, you kind of felt like, if their experiments are working, maybe that's what I need to do to get my experiments working. And, in my case, that was not how it worked. The longer hours really didn't help at all. It was just more time that I spent at the bench when I should have probably spent reading and thinking. But yeah, I think that there's something true about these problems in our work culture, both this pressure to work long hours and these lack of worker protections.
Mm-hmm.
I think especially when I moved to Switzerland, I really felt this sense of
well, yeah, you are not valued for long hours. Actually,
exactly.
It can be also otherwise. Actually,
exactly. So if you don't leave before 7, then you're not going to go to the grocery. So people left on time, and I think there was even this attitude that if you're working long hours, it's because you haven't organized yourself well.
Yes,
and for me, that attitude did help because it sort of pushed me in the direction of reading more, thinking more, and spending my time more judiciously. And, it's hard to compare directly because, of course, I was a student in the US and I had some experience for my first postdoc. But for me, it was definitely more efficient and more effective to work shorter hours, but with more thinking time. Yeah, other than the working hours, there's also this story of the worker protections. So in Switzerland, it was still private healthcare. In Spain, there's public healthcare.
Yeah.
And I recently had a baby here, and I have to tell you, thank you. Yeah, the public healthcare is amazing. The maternity leave and paternity leave are amazing. The social programs have made all the difference in making this experience seem pretty much like I didn't even really consider becoming a parent in the US. And here it's been a very nice experience. It's still early days. I'm sure, but like it's not like it's not stressful. It's still stressful, but there are a lot of structural advantages to being a parent here that were not there for me in the US.
Yeah, then definitely it's a huge plus in the bunch of opportunities, and it makes your life a little bit easier, even taking into consideration that giving birth is not an easy experience at all.
No.
But everything
Definitely.
else what happens afterwards is more highly demanding even than before. Yeah.
Absolutely.
Yeah, but definitely yes, when you can stay like together with your baby and spend some time, you cannot even, I think, measure the
value of that.
Yeah, the value of it, and being at least to get accustomed with the thought that you are a parent right now. Yeah, so this definitely yes. And do you need any security or some specifically dedicated healthcare in Spain? I mean, or is it just the public healthcare what you need there?
It's just the public, and
Okay.
I was amazed because I don't know if this story is relevant or not, but I'll share it. That I had a private insurance when I came to Spain because that's a requirement of the initial stages of the immigration. And when I became pregnant, they immediately dropped me. They found a loophole. And on the converse side, the public health insurance here, because I was pregnant, made an exception and allowed me to get on the public insurance earlier than the typical immigration path would allow, which was just such a fundamentally different experience of insurance for me.
Yeah, that sounds great, actually.
Yes, yeah. In terms of these worker protections, these social safety net things, they're a dream here. Yeah. On the converse, I would say one big advantage that was there in the US that I'm finding is more difficult here is the amount of administrative support structure that we had. And maybe it was my institute specifically, but there was an international office, there were secretaries for every professor, there were legal departments, and I found that in Switzerland, somewhat, and here especially, there's a lot of all of that stuff that I need to do for myself.
Yeah, administrative burden on researchers themselves. Yeah,
Yeah.
your own secretary, lawyer, and
exactly. I found myself writing a lot of legal documents, which I am not in any way an expert in since I've been here.
But one more question about this. The support, I mean, on migration things that you need a visa or something like that. How was it with this bureaucratic things?
It was very difficult.
Hard.
It was. I was, because I had seen the inverse, that I had seen the postdocs that had come to the US and seen their experiences. It didn't look, I mean, there were people who had bad experiences, especially if they came from third countries, if they came from Russia, if they came from China. It was much more difficult for them, but those were sort of related to the immigration laws themselves. The administrators were doing as much as they could to support those people. I felt like for me, there was a lot of stuff that I had to do on my own, and also in the language of the region,
Yeah,
which was very complicated for me.
And in Switzerland, basically, I understand that the modern language of science is English everywhere.
Yes.
There is no issue about that. But otherwise, did you had to study some German in Switzerland and French and now Spanish?
Yeah, so I was in Geneva, so it was the French-speaking part of Switzerland. And I had done some Duolingo to prepare myself. I knew the basics of French, but I really regretted not spending more time learning the language before, because although the day-to-day interactions in the lab were all in English, the life is in French. And so just it made tasks like going to the post office or ordering in a restaurant sort of paralyzing, and I wish I had spent more time learning the language. So for Spain, I had been speaking Spanish at home with my husband and his family for a while, and so when I came here, I already had much more experience with the language, and it's made it so much more enriching to be here, to be able to have small conversations with people in the grocery store or in the children's park. It really increases the sense of belonging.
Yeah, that's definitely a topic that someone should at least be prepared. That basically you can speak English everywhere, but still this national language, at least operating on a like B1 level is a huge advantage for you.
It definitely is.
And going back to the process of migration, more specifically the research mobility, concerning your path in the Marie Skłodowska-Curie actions, was it according to plan? Did you have any deviations from this path?
Well, from a research perspective, with my first Marie Curie, nothing went according to plan. I think everything that I wrote in that proposal ended up being different than I had hoped, and I actually ended up the final project ended up being on a protein that was contaminating the proteins I was supposed to be studying.
Okay. And
At the
how
same
does
time,
it reporting period? How does it went through reporting? Everything was fine.
yeah,
You was persuasive.
it was persuasive in the end because the work that I had done to prepare the proposal actually guided my thinking as I developed the final topic. And as much as that project started as a disaster, it ended up being a Nature paper. So it was very lucky.
That's a common practice in biology, penicillin and so on. So from tricky
Exactly.
situations, you usually get good results.
I think that's definitely true.
But what are your plans for the future? Tell us, where do you plan to stay, carry out your research, or anything else that is on your mind?
Yeah, so I plan on settling here. This is where our family is, and it's a really great environment both for working and for living. There are some mechanisms for stabilizing here from the Spanish government. There's the ERC. So I am in the process
Yes.
now of thinking about gathering enough preliminary data to start applying these things. And yeah, the dream would be to stabilize within the group that I'm in right now, because there are several other postdocs in the lab that are going down the same path, and so they're nice examples for me. And yeah, I would love to carry out the rest of my research career here.
And taking into account that your research career and transition from the US to the EU were successful, even though you obviously had hurdles to overcome. Do you have any suggestions for other researchers that are willing to switch from the US to Europe, or for those who are already in Europe, on how to be good researchers and which tips and tricks they can use to enhance their research careers?
Yeah, I mean, I think it's all about flexibility and going where the big questions are being answered. Um, I think the biggest tip I have for any early career researcher is, have conversations with the people you think are doing amazing science. Have conversations about science, and it's super nice to talk to people that are from different parts of the world that are working on different subjects, and see what's out there and make those connections. Um,
That's something that usually people from the research community forget about, but it is an important thing. Networking inside the scientific community, conferences, projects, and everything like that, in order to brainstorm and get new ideas. So I completely agree. Even though I'm an introvert a bit myself, so for me it's a bit hard to do this.
No, it challenges you and takes you to the next level.
and I hope
Yeah.
I think it helps like cultivate this understanding of what are the big problems that need to be solved.
And in the case of mechanobiologists, also the small problems that have big solutions and big applications.
Exactly.
Great. Thank you very much, Jennifer. It was a pleasure to talk to you, to know your specific field that is not something definitely that people usually discuss around a cup of tea. not like in your lab, probably.
I was going to say, I would disagree with that.
You have your reasons. I'm not opposing here, but it's very interesting how people from different disciplines and from US that came to Europe, some has their roots already there. Just because of that, they explore again, returning to Europe and going back to US, and you are like from US and coming to Europe to stay. Thank you very much for all your information. I think it's a nice story that gives early stage researchers at least understanding how they can start exploring. And yes, that definitely you should take this challenge of mobility sometimes. Yeah, I understand that how difficult it could be, but yeah, in case you are at least single, then definitely explore. Yeah, thank you very much for your time and for all these new facts that we need to think about.
Oh, thank you.
Thank you for listening to this episode of the EURAXESS Smart Talks podcast.
We hope that you enjoyed this episode and can't wait to share more with you next time.
You can follow us and find more episodes on the EURAXESS portal, our social media profiles, or wherever you listen to podcasts.
This episode was prepared by hosts Daria Aksjonova and Jovan Aranđelović, editor Isar Peer, and is dedicated in memoriam of Professor Miroslav Trajanović.